Alright guys, so this is the video for section 1-4A, and in this video we're going to talk about polygons and how we classify them. Okay, so a figure that lies in a plane is called a plane figure. So remember, a plane is a flat surface that goes on forever. So when I talk about a plane figure, think of it's anything that you can draw, like, I don't know, on a piece of paper. So it's two-dimensional, okay? We're not talking about a 3D cube or anything. It's just two-dimensional. All right, so more specifically, a polygon is a closed plane figure formed by 3 or more sides. Okay, so we can have as few as 3 sides. So a 3-sided polygon would look like this. Okay, and obviously that's a triangle, or we can have as many sides as we want. We can have, 576 sides if we want. All right, so each side is a line segment. So in a polygon, we would call, like, this side here, that's a segment. This side's a segment. This side's a segment, okay? Remember, segments start and stop. So each of these sides are segments, and each segment connects to what we call a vertex. Okay, so no two sides with a common vertex are collinear. So we do change at each vertex. We change directions. All right, so the number of sides, which is also the same as the number of angles, determines what type of polygon we have. Okay, so you can name a polygon using the term n-gon when it has n number of sides. So for example, if we have a 14-gon, this is just a polygon with 14 sides. All right, so let's review some of the main types of polygons that we don't use gon with. They have real names because we use them more often. So a 3-sided polygon is a triangle. We should know that. Okay, 4-sided is a quadrilateral. A 5-sided polygon we know is a pentagon. 6-sided is a hexagon. 7 is a heptagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon. 11 is a hendecagon. And 12 is a dodecagon. Okay, you should know all of those. And if you don't, you probably should learn them. Spend some time and learn them. All right, so now we're going to go to concave and convex. So each polygon is either a concave polygon or a convex polygon. Okay, so a polygon is convex when no line that contains a side of the polygon contains a point in the interior. So basically, as this figure shows, if we extend every one of these sides, okay, we're just going to extend it in both directions. We make it a segment to a line, okay? None of those lines will go inside of the polygon, okay? They all stay on the exterior of it, okay? A concave polygon, on the other hand, one or more lines that you draw, so like notice this segment here, if we extend it, go this way to be a line, we go right through the middle. Okay, that would make it concave. Okay, now the way I like to remember that is concave polygons, it looks like one side is caving in. That's how I remember it. All right, so let's look at this example. Okay, we want to classify the number of polygons by the number of sides and tell whether it is concave or convex. All right, so let's look at this. All right, let's look at A. So we have one side, 2, 3, 4, 5, 6 sides. Okay, so we know a 6th side is called a hexagon. Okay, now I need to look, if I extend all of these sides, okay, does any of them go through the hexagon? Does any of them go in the interior? Okay, well, as I can see, no, they don't. They all stay in the exterior. So that means this is a convex hexagon, and that's what we would name it. All right, let's look at B now. Okay, now first of all, we know this looks like it's caving in. Okay, so if I draw this line here and I continue it, if I make that segment into a line, it goes right through the middle of this polygon. So I can stop there. I don't have to test all the sides. Here I know we have a concave polygon. So I'm gonna write concave. Now the question is, how many sides does it have? Okay, so we have a one side here, two sides, three sides, four sides. Okay, and all four-sided sides are called quadrilaterals. Okay, so we would call B a concave quadrilateral. All right, so I want you to pause this video and try to do C and D on your own, and then we'll go over them when you come back. All right, so hopefully you've worked through this, but let's go ahead and do these. So to find the number of sides, I have one side, two, three, four, five sides, which means I'm dealing with a pentagon. Okay, and notice right here, it looks like I'm caving in, so I'm going to test one of these sides. So if I make this segment a line right here, I'm going on the inside of that polygon. So it is in fact concave. So I would call this a concave pentagon. Okay, now on D, okay, one side, two sides, three, four, five, six, seven. So 7 sides is called a heptagon. Okay, now the question is, do any of those go in the interior if I extend them to lines? So make that segment a line, that one a line, this one. So far we're clean. This one. We don't. So if we continue every one of those sides, none of them will go into the interior. So this would be a convex heptagon.